Welcome back, my aspiring mathematicians. Today I'm going to discuss a topic in geometry, and that topic has to do with congruence criteria. If we are given two triangles, we are usually asked to prove if those two triangles are congruent using one of the 5 congruence criteria. And the 5 congruence criteria that we can use to prove that two triangles are congruent are AAS, ASA, SAS, SSS, and HL. There are 2 criteria that we cannot use to prove that two triangles are congruent, and those 2 criteria are SSA and AAA, or what we'll say AAA. In terms of the unit on congruence, we are always asked to write a proof, and some students struggle with writing a proof for congruence and also for similarity. Today I'm going to show you how to write a proof using AAS, and also I'm going to show you that it is an extension of ASA. So let's get right into what is AAS, and I'm going to show you what it means and how we can write a proof using an example that's given to you. In order to start writing a proof, you always have the given, and then they ask you to prove something. And in terms of writing it out, you have to have 2 columns. You have to have the statement and the reason column. So first and foremost, let's start with an example here of an AAS, and I'm going to show you what it looks like and how you can write a proof based on the given information here. So before we get started with writing a proof, I want to show you some symbols and tell you what they mean so that you can identify and relate to it and know what to do and what it means when you are writing your proof. So first and foremost, if you are given an example like this, ST, that this is simply means with the line over the letters that this is a segment. So that is a segment ST. And if you have this symbol here, which is this symbol, that simply means that that is an angle. So the first thing that you need to do when you are writing a proof is that you are going to start with 2 columns. You're going to start with a statement and a reason column, and then you are going to first write your given. So let's get started with that. So you have your statement, your S, and your R for reason, and I'm going to create 2 columns here. And your first given is that segment ST is equals to segment WX. So the first is ST is equal to WX, and that's the segment, and that's your given. Now for that given, because you look at that, you can mark it off on your diagram. So ST is going to be congruent to WX, and you mark it that way because you want to denote it on your diagram. So you can literally see it, and you can put S right here and S right here. I always tell my students do that. If it's an angle, you put A. The next given is that angle X is congruent to angle T. So angle X is right here, and it's going to be congruent to angle T. So you put an arc there to show, and you put the letter A, and you put the letter A right there. And now you also write that given. So angle X is going to be congruent to angle T, and that's your given. So another thing that I tell my students also is that they should put the letter that denotes whether it's a segment or an angle beside whether it's your given or if it is your reason that you are formulating from evidence that you see. So you will have your A right here for the angle. The next thing that you'll notice here is that it tells you that angle TUS, and I'm going to put 2 arcs here because I want to differentiate this first angle with the second angle, and I'm going to put an A here, and the other one, which is angle X, Y, W, 2 arcs again, and you put your A there. So now you can write that also as your second given. So your third one is angle TUS is congruent to angle X, Y, W. And I want to also tell you that you will notice that you can write what an angle is in 3 ways. If it is at a vertex like here for T, you can say angle T by itself, and then you can also use the 3 letters of the alphabet, or 3 letters that is given, and the middle letter is going to tell you where that angle is located. So normally, so in this case, if we have, say for instance, we had STU, we would mean that angle STU, right, meaning that angle T is going to be congruent to angle WXY. It's the same thing as saying angle X. Because of where it is at a vertex and it is not a split angle. Okay, so now we have that, right? And we have AAS. Now, because we have AAS, we can also go ahead now and we can write that these 2 triangles are congruent by AAS. So the first one we write, or the fourth statement, is that triangle, and we are talking about here triangle STU is congruent to triangle, and this is the symbol for triangle, just a triangle, we draw that, WXY, and that is by the congruence criteria AAS congruence criteria. Okay? This is what it is. Angle, angle, side. Now, angle, angle, side is simply telling you that you have 2 angles and then a side. So you have 2 angles coming side by side and then a side. We read it like this, saying angle, angle, side. But one thing you should note on this example is that look at these 2 triangles. If 2 angles are congruent in a triangle, right, then wouldn't it be obvious that the third angle is going to be congruent? Yeah. So if you have 2 angles in a triangle, right, that are congruent to another pair of angles in the other triangle, then yes, the third angle is going to be congruent also. And this is why we would normally say that AAS is an extension of the other congruence criteria, which is ASA. So in this example, we can also say that this would be the third angle here, and I'm putting right here 3 arcs to denote that these 2 angles are congruent, right? And this is an angle here, and this is an angle here. Looking at this, we will note that AAS is also an extension of ASA because of the fact that if 2 angles in a triangle are congruent to another 2 angles in another triangle, then the third angle is also going to be congruent. So that concludes what it means by AAS is an extension of ASA. So we have here, and when you're doing it or writing it, what I want to show you, when you are doing this type of problem, you're saying that AAS here, right? And this is the AS AAS. It's coming from that direction. But if I take it from another level and I start here, ASA, then you can see that AAS, right, is an extension of ASA. Only because if two angles in a triangle are congruent to the other two angles in another triangle, then obviously the third angle is going to be congruent, and hence you can also say that ASA is an extension of AAS. Or you can also say that the triangle is also congruent by ASA. As you should know by now, I like to give various examples. So now that we have established what AAS is, and if you notice, you have an angle, and then a side. But for ASA, you have an angle, a side, and followed by another angle. It must follow each other. You cannot say A. No, plus you can't use that anyhow. So you can't use that to say that two triangles are congruent. All right, so you have to make sure that you know that. So notice it comes in line, AAS or ASA. Now I'm going to get into the next example where you are going to be given some information and then you have to write a proof about it and prove that the two triangles are congruent, and you have to decide what are they congruent by. But this is the congruence criteria of AAS that I am using today. So before we get started in writing proofs, there are three things that you should be looking for when you are given two diagrams or two triangles, or it could be one big diagram with several triangles in there. You have to look out for vertical angles. You have to look out for the reflexive property, or what we call the common side. And you also should look to see if there is a common angle, which in general, having a common angle is simply meaning that that angle is being shared by the two triangles that you are working with. And if you have a vertical angles are usually formed when you have two angles that are opposite each other. They're vertical to each other. And obviously the reflexive property, or what we call the common side, that comes into play when you are sharing a side for both triangles. The next example here that I'm going to write a proof on is given to you, and it states that given that segment BD bisects angle ABC and angle BAT is congruent to angle BCD, we're to prove that triangle BAD is congruent to triangle BCD. So let's get started with this. First and foremost, once again, start with your statement and reason column, and you are going to get started here now. Looking at what we have here, segment BD bisects angle BAD. This is the angle that it bisects that, okay? So we are going to write down our given 1 BD bisects angle ABC, and that's a given. Then the next given that we have is angle BAD is congruent to angle BCD, and that's a given. Since you have that, if BD is an angle bisector, right? This segment is an angle bisector of ABC, then that means that this angle right here is going to be congruent to this angle. So you can put that for A right there, okay? So then you can say that for the third one, statement that you're going to write is that since it's an angle bisector, it's going to split the angle B in two or in half. So angle ABD, angle ABD is going to be congruent to angle CBD. And that's by definition of angle bisector. Then they also told you that angle BAD, that's this angle right here, is congruent to angle BCD. And this, you do two arcs here to show that these two angles are congruent. You want to separate it from the ones with one arc, and this is an angle. You put A there for an angle, and you're going to write it here. And that was our given because angle BAD is congruent to that. Right here, because you know that it is an angle, you can write on here that this is A. This is also A right here. Okay? When you're writing proof, you have to write what's given and then pull something from the diagram. We can literally pull something from this diagram. And you can pull BD, segment BD, would now be the, what we call it, the reflexive property or the common side. So we can literally say that this is going to be your common side or the reflexive property. Now, another thing I want to say to you, I don't want you to assume that this angle right here, BDA, and angle BDC is going to form a right angle. I don't want you to assume that. That's making an assumption, and you know what that means. ASS, and we don't use that out of you and me. So don't make that assumption. It was nothing that was given or stated, so you should not assume. Do not come up with that. You may want to look so, but please be careful. They specifically spoke about the angle bisector, so use what is given to you. All right. So now you have that there. You're going to write what you are taking from that and diagram, because you notice angle BAD, this is one side. And I always tell my student also, if this helps where you are highlighting one triangle, which is triangle BAD, and then you can also highlight the other triangle, which is BCD, with a different color, that would give you a visual of the two triangles that you're trying to prove. Because sometimes you might have a large triangle and say maybe 2 or 3 other triangles going on there. Once you're able to highlight which triangles you're dealing with, then you can get that visual picture and see what can be taken out of that picture. We are going to write our fourth one because we have 3 already, and now we are going to say that segment BD is going to be congruent to segment BD, or even if you write DB, even if you switch the letters around, it doesn't matter, okay? And you write instead, it could be written, or you can write it as segment BD is congruent to segment DB. It doesn't matter, all right? And then you can say this is what we call the reflexive property, right? Or sometimes you might see the word common side. And when you see that, you now know that that is going to be a segment, so you put S right here. And you have your S here. So now you can notice that you have AAS, right? We're not coming from this way because we cannot write anything about this because it is not correct, or it is not something that is given to us. We cannot assume, so we cannot do anything with this angle here. So we are simply going to close off now with our next statement, our last and final one. And we are going to say triangle BAD is congruent to triangle BCD, and that is by AAS congruence criteria. So looking at this picture, you will notice that if these two angles in a triangle BAD is congruent to the other two angles in triangle BCD, then evidently the third angle would be congruent to this angle, but we are not going to assume that this will be a right angle. Do not make that assumption. Okay, so I just want you to know that if they stated that BD is perpendicular to AC, then you can come to the conclusion and say that this angle BDA and angle BDC would be 90-degree angles, or would be a right angle, only if they had given the information that segment BD is perpendicular to segment AC. And then if that was the case, then you could simply say that as the reason when you write it and you say BDA is congruent to BDC, then for your reason you would simply write definition of perpendicular bisector from right angles. So definitely now, as I stated, that the third angle would be congruent to the next angle. Therefore, you can see also the other extension here, and you could say that this angle would be congruent to this angle, which would be an A, and also now you would see that AAS is an extension of ASA. So I just wanted to show you that AAS is indeed an extension of ASA. So in conclusion, when you are writing proofs, there are three things that you must look out for. You must look out for reflexive property or common side. You must look out for common angle or vertical angles. And now that you know how to write a proof given to you and use the ASA congruence criteria, and you also note that the ASA congruence criteria is an extension of AAS. So with that being said, if you have not yet subscribed to my channel, what are you waiting for? Go ahead and hit that subscribe button, and do remember to share this video with others around the world so they too can learn about congruence and how to write proof. Thank you for watching, and see you soon on the next video to come. Bye now.